Good day everyone! In today's tutorial, we will learn how to solve for arithmetic sequences. So this will be our objectives and you listen very well in order for us to learn. Many objects around us exhibit patterns. Stacks of grocery boxes, kilometer markers, and countdown timers are some examples that use patterns of numbers. In this lesson, we will learn about different kinds of sequences and how the terms these sequences are obtained. A sequence is a set of numbers that are arranged in a specific order. In the given sequence, a sub 1 is our first term. The second term is the term after the first term, that is a sub 2, and we have the nth term, or what we call the general term or the last term, or the term asked for you to find out. So let's have an example. In our given 2, 5, 8, 11, 26, 29, 2 is the first term and 29 is the last term. How about this one? So negative 1 is our first term, but as you can see, we have the three dots or what we call ellipses. So the ellipsis found at the end of a sequence indicates that the sequence is infinite. Another example. So can you identify the first term and the last term? Okay, that's very good. And the two examples with the first term and the last term is what we call a finite sequence. Finite sequence is determined having the last term. And the infinite sequence, our clue is it has an ellipsis. Ellipsis tells us that the sequence is infinite. So it doesn't have the last term yet. So for your comment number 1, or what will you answer number 1? Give an example of an infinite sequence. Any number, that's your comment number 1. So what is an arithmetic sequence? An arithmetic sequence is a sequence whose consecutive terms have common difference. So we have there the term common difference. So how will we do that? In the given sequence 2, 5, 8, 11 and negative 2, negative 5 and so on. So how do we find or determine whether the sequence is an arithmetic sequence or not? We have to check whether the differences between the consecutive terms are constant. So let's see. So for the first one, subtract the A1, 8 sub 2 to A sub 1. So that is 5 minus 2, that will give you 3. And 8 minus 5, that is 3. 11 minus 8 is 3. So is the sequence having common difference? So let's see. It is an arithmetic sequence because the common difference is 3. How about the second example? So negative 5, that A sub 2 minus A sub 1, that is negative 2, that will give you negative 3, and 3 minus negative 5 is 8. So doon pa lang malalaman nyo that the example is not an arithmetic sequence. Okay. So for your comment number 2, this is your question. So kung medyo mabilis, please pause or have the screenshot of this video, of this part. Comment number 2, is the sequence 2, 5, 8, 11, 15 an arithmetic sequence? So defend your answer. How will you answer this? You have the examples that I have given you, so you just follow that one. Okay, let's try to learn this example. Give the first 5 terms of an arithmetic sequence whose common difference D is 8 and whose first term A sub 1 is negative 3. So how do we do that? Let's have the solution. To find A sub 1, or write the A sub 1 first, that's negative 3 and D is 8. So where did we get those? It's all here in your given. So you just write it in your solution. And substitute, find the common difference. How do you find the common difference? That is A sub 2 minus A sub 1. That's the formula to find the common difference. So just subtract a sub 1 from a sub 2, and then substitute since we are given a sub 1 here. Your a sub 1 is -3 and your common difference is 8, and simplify. That will give you a sub 2 is equal to a 8 minus 3, and a sub 2 is equal to 5. So we already have now a sub 1 and a sub 2. Now let's look for a sub 3. How do we find or solve for a sub 3? To solve for a sub 3, we use our a sub 2, which we have solved just a while ago. So that's 5 plus our common difference of that's 8. 5 plus 8 is equal to 13. And continue looking for your a sub 4 and your a sub 5. And for our conclusion, the first 5 terms of the arithmetic sequence are -3, 5, 13, 21, and 29. So how do we get -3? This is our a sub 1. This is given. Okay? So how do you find 5? 5 is our a sub 2 here. And we have 13 as our a sub 3. A sub 4 is 21. And our a sub 5 is 29. So we answered our problem. First 5 terms. So here are the first 5 terms. 1, 2, 3, 4, and let's have another example. What is the 50th term in the arithmetic sequence? We've given our a sub 1 and the common difference. Right? So how do we do that? Do we write the solution, or first we write the formula? What formula that will be used to find the 50th term, and then substitute? Why 50? I have discussed this already with you, and it's our nth term. So we are looking for the 50th. Then substitute. 50 here is our n, and b here is our common difference as given in our problem. And then simplify. So if you can see 58.8 here become 58.5. Why? Because our given here as our first term is negative. That is 0.3, negative 0.3 plus 58.5. So you have to subtract 58.5 and 0.3. 58.5 minus 0.3 is 58.8 minus 0.3 is 58.5. So your for comment number 3. Find the 20th term of the arithmetic sequence with our first term as 7 and common difference as 2. So you just have to follow this pattern, follow this formula, this formula. Again, I am telling you, math is a pattern. Mathematics is a pattern. So as you can see, we have to follow certain pattern in mathematics. Okay, let us now discuss the arithmetic series. An arithmetic series is the sum of terms of a sequence. It is a group of numbers separated by a plus sign, and in particular, an arithmetic series is the sum of terms of an arithmetic sequence. So as you can see here in our illustration, S sub n is 3 plus 6 plus 9 plus 12 plus 15. And S of 5 is just as given. So why S of 5? S of 5 because we have 5 terms. So that is the number of terms. So let's continue. Let us consider the sequence 3, 5, 7, 9, 11, 13, and 15. So can we find the sum of the corresponding series 7? So the sum of the terms or S7, how we can do that? So you just add using the associative property of addition. The sum of the 7 terms of the arithmetic series is 63. So how do you do that? Just add the numbers, and since the given numbers are 7, 3, 5, 7, 9, 13, 11, 13, and 15, can use your calculator or can add that manually. And in addition, the sum of the first terms of n terms, of the first n terms, the number of terms of an arithmetic sequence is given by this formula. And furthermore, since a sub n, so you can use either of this formula, is equal to a sub 1 plus n minus 1 is d times d. So you can also use this formula. Okay, so this a sub 1 is just substituted in here, in a sub 1, in a sub n. Okay, so I hope you understand Another type of sequence is the geometric sequence. A geometric sequence is a sequence whose consecutive terms have a common ratio r. Now let's see, in the given, is it a geometric sequence? So let's see. So I have here two givens. Let us check if the first given is a geometric sequence. In the geometric sequence, in the given, here, it is a geometric sequence because each term is obtained from the previous one by multiplying it by 2, which is the common ratio. So let's see, is that true? 2 times 2 is 4. Is 4 minus times 2, 8 times 2, 16. 16 times 2, 32 times 2, 64 times 2, and so on. Okay, and how about here, example number 2, is our given geometric or not? So let's see, if the common ratio is 1/2, that is another example of a geometric sequence. How about the third example? Is that a geometric sequence or not? So let's see, how do we find r square root of 2? You have to recall to rationalize expressions with radical in the denominator. So how do you do that? Just look at that. 2 square root of 2. How do you rationalize that one? So you divide that by square root of 2 to rationalize the expressions with radicals in the denominator. Alright, so for our theorem, the nth term of geometric sequence with a sub 1 as the first term and r as the common ratio is given in this formula. So let us have an example. So let's find the missing terms in the geometric sequence as given. So we have two missing terms. How do we do that? So use our formula given in our theorem. Okay? So a sub 1 is our first term and r as our common ratio. So just substitute. How do we do that? A sub n, how many terms? Okay, and a sub 1 is equal to r n minus 1. Okay, so why only r3? Why a sub 3? Because we are given this. Okay, a sub 3, given kasi yung ating third term. Okay, so we will use the given, yung 1. To find our r. So remember that one and don't get confused. So bakit natin ginamit yung 1? Because 1 is already given. May hinahanap tayong nawawala. So ang gagamitin natin is the given. So a sub 3, 144. Why 144? That is given as our a sub 1. The first term. R, that will be the ratio. We'll be looking for the ratio first. 3 minus 1. Why 3? Because 1, that is our and we are using 1 here, so we are using our third term. Okay, then continuing, a sub 3 is 144 r squared. So why r squared? That is 3 minus 1 is r squared. So how do we do this? So find the square root of 144, giving you positive or negative 1 over 12. So using when r is positive 1 over 12, what is our a sub 2 and a sub 4? So since meron na tayong a sub 1, 3, and 5, we are looking for a sub 2 here and a sub 4 here. So just substitute using this one. So a sub 2 is 144 times 1 over 12. We will be using the positive value first. Remember, we have two values here, positive 1 over 12 and negative 1 over 12. So we will be using the positive value first and multiply that by 1/2. So why multiply? Because we are now dealing with ratio. In our last lesson, we are dealing with the common difference. That is why we just added or subtracted. But in the ratio, to find ratio, we have to multiply. Or if you want to do it the other way around, you have to divide. So in this case, let us stick to this given. 144 times 1 over 12 is 12. How do you do that? 144 times 1 is 144 divided by 12. That will give you 12. And for a sub 4 here, our fourth term, 1, y1. Okay, what are we using here? Times 12. Times 12, that is 1 over 12. Okay, so let's continue. How about when r is negative 1 over 12? So why are we using again negative 12? Because our a sub 3 is positive negative 1 over 12. So that's, again, we will be using here a sub 2. So use 144 times negative 1 over 12. That will give you negative 12. We will be using 1. We are, again, a reminder, we are looking for the ratio. So we are using ratio now. So 1 times negative 1 over 12 is negative 1 over 12. Okay, so we have two ways for our conclusion. The first one here is the answer using when r or the ratio is positive 1/12 or 1 over 12. So we'll be filling up this a sub 2 and a sub 4 using first when r is 1 over 12. And for this part, 144, why negative 12? We use the value when r is negative 12, then fill up a sub 2 here and a sub 4. Okay, so for our comment number 4, what do we do? Use the lesson just a while ago to determine the ratio of a geometric sequence with the first term, negative 2, and the fourth term, 27 over 4. So good luck, guys! Okay, so this is just an addition. Geometric sequence, as you can see, it's just listed with a comma or an ellipsis to tell you that there are still numbers in between a sub 2 and a sub n. So what's the difference with geometric sequence and geometric series? So as you can see, just like the arithmetic sequence and series, the geometric series is the sum of terms of the geometric sequence. So when you say sum, we have to see this symbol or the plus sign. In this way, you can identify if the given is a geometric sequence or a geometric series. So using this theorem 1.4, so how do we use this? The sum of the first n terms of a geometric sequence is given by this formula. So what are the problems that can be used using this formula? So if the problem asks you to find the sum of the geometric series or and so on, use theorem 1-4 or this formula. Don't worry, you don't have to remember the number of the theorem. You just have to remember this formula. So if the question starts with or ends with find the sum of the geometric series, use this formula. And if the sum S of an infinite geometric series is given by this formula, but just remember that the ratio is less than 1. Okay? Your problem should start or should have or be asking you find the sum of the infinite geometric series. So the problem goes that way. Okay? So let's have the last one. So our comment number 5 or question number 5 is a bit bonus for my students. Write the complete name of our school director. So it should be complete. Do not forget to subscribe to our YouTube channel, Marilyn Lim, so that you can be notified for new videos, math videos. Thank you so much. God bless us all.